Okay, we're going to look at the discriminant and conditions of the discriminant. Remember, the discriminant is b squared minus 4ac. So when the discriminant is greater than the 0, the roots are real and distinct. When b squared minus 4ac, the discriminant is equal to 0, then the roots are real and equal. When b squared minus 4ac, the discriminant is less than 0, that means that the roots are unreal. And when b squared minus 4ac is greater than or equal to 0, so we're kind of hedging our bets there, we don't know if it's greater than 0 or equal to 0. Well, all we can say with complete confidence there is that the roots are real. Okay, so let's look at some questions. Example 1, we're going to find the nature of the roots given 9x squared plus 24x is equal to minus 16. So the first thing that I'll do is make the quadratic equation equal to 0. So it'll be 9x squared plus 24x plus 16 is equal to 0. A is 9, B is 24, and C is equal to 16. So then I go about the business of calculating the discriminant. So b squared minus 4ac, so that will be 24 squared minus 4 times 9 times 16, and that's 576 minus 576 equals 0. So d equals 0, therefore roots are real and equal. Okay, example 2. Find the values of q such that 6x squared plus 12x plus q equals 0 has real roots. Okay, so for real roots, then let's list the condition, which would probably gain as a mark in itself, that the discriminant b squared minus 4ac is greater than or equal to 0. Now let's identify a, b and c. A is 6, b is 12, and c is equal to q. So then that's 12 squared minus 4 times a, which is 6, times c, which is q, is greater than or equal to 0. That's 144 minus 4 sixes are 24, minus 24q is greater than or equal to 0. We've then got minus 24q is greater than or equal to, so bring the 144 over, it'll become minus 144. I'm then going to divide through by a negative number, so I'll flip that inequality round, and it's minus 144 divided by minus 24. And the negative divided by the negative cancels out, and 24 fits into 144 6 times, so final answer is q is less than or equal to 6. Okay, next question. We're going to find the range of values for k, for which the equation kx squared plus 2x minus 7 equals 0 has no real roots or unreal roots. So the condition for the discriminant this time for no real roots is that the discriminant is b squared minus 4ac will be less than 0. I can then identify a, b and c. A is equal to k, b is 2, and c is minus 7. So a is k, b is 2, and c is minus 7. So b squared minus 4ac is less than 0. it'll be 2 squared minus 4 times a, which is k, times c, which is minus 7, will be less than 0. That's 4. So minus 4 times k is minus 4k. Minus 4k times minus 7 is plus 28k. It's less than 0. I've then got the 28k will be less than minus 4 by bringing that across. K will be less than minus 4 over 28. I can then divide top and bottom by 2. And that will be by 4 rather, and that will be k is less than minus 1 over 7. Okay, next question. Show that 2k plus 4 x squared plus 3k plus 2 x plus k minus 2 equals 0 has real roots for all values of k. Okay, so the condition for real roots is that b squared minus 4ac is greater than or equal to 0. I'll next identify a, b and c. So a is the coefficient in front of x squared, that's 2k plus 4. B is the coefficient in front of x, that's 3k plus 2. And c is everything else, so that's k minus 2. So a equals 2k plus 4. B equals 3k plus 2. And c is equal to k minus 2. So let's put that into the discriminant. B squared minus 4ac. So b squared, b is 3k plus 2, so it'll be 3k plus 2 all squared. Minus 4 times c, which is k minus 2, times a, which is 2k plus 4. I should really have put them the other way around, but the same difference. Okay, so opening up this squared bracket will give me 9k squared plus 6k plus another 6k plus 4 minus, and I can put these two together, and that will give me 4k minus 8 bracket 2k plus 4. So just tidying up some terms here, that will be 9k squared plus 12k plus 4 minus, so I'll use a bit of FOIL method here, so 4k times 2k is 8k squared, and I'm putting all this inside of a bracket with the minus out in front. And then outside 4k times 4 will be 16k, inside's minus 8 times 2k, minus 16k, and then minus 8 times 4 is minus 32. So that's now 9k squared plus 12k plus 40. Those would have cancelled out, minus 8k squared. And then I've got a minus 32 is plus 32. So 9k squared minus 8k squared is k squared. I've got plus 12k, and then 40 and 32. So in fact it's not 40 but 4 plus 32 is plus 36. I can now factorise, so two numbers multiplied give 36, add together give 12 is 6 and 6. So that'll give me k plus 6 bracket k plus 6, which I can write as k plus 6 all squared. Now, because this is an expression which has been squared, then everything squared needs to be greater than or equal to 0, so I can say with complete confidence that that is greater than or equal to 0 for all values of k. Therefore, roots are always real. Okay, so next question. Show that the roots of p minus 2x squared minus 3p minus 2 together, x plus 2p equals 0 are always real. So a similar type of question to the last one. So let's practice that again. So the condition for the discriminant when the roots are always real is that it's greater than or equal to 0. A is equal to p minus 2. B is equal to minus 3p minus 2. And C is equal to 2p. So b squared minus 4ac so that will be minus 3p minus 2 all squared minus 4 times p minus 2 times c, which is 2p. Okay, so by squaring the negative, I'll get a positive, so that will be 3p minus 2 all squared minus 4 lots of 2 is 8p times p minus 2. So that will be 9p squared minus 6p minus 6p plus 4 minus 8p squared plus 16p. So then 9p squared minus 8p squared is p squared, minus 6p minus 6p is minus 12p plus 16p is plus 4p plus 4. Two numbers that multiply give 4, I have to give 4 is 2 and 2. So p plus 2, that's p plus 2 all squared is greater than or equal to 0 for all values of p. Therefore, roots are always real.